Alrighty, today we're going to be looking at 913, deciding which method should we use in order to solve and simplify and find the roots of a quadratic equation. We have three methods to choose from. We have the vertex form of a parabola, which would be y equals a times x minus h, quantity squared, plus k on the outside. Vertex form, and using the zero product property with the vertex form, is great when we have two different situations. One situation is when we have a special case of a perfect square trinomial. When we have a perfect square trinomial, we're going to rewrite the equation into vertex form automatically. So that's the first situation in which we would use perfect square trinomial. We have the same base twice, which means it's going to be automatically put into vertex form. The other situation that might be simpler to use vertex form would be if we have a quadratic equation that has the x squared all by itself, meaning that we have an equation such as y equals x squared, and then whatever the b value is, if it's even. If it's an even number, like 2, 4, 6, 8, or -2, -4, -6, -8, all with the x attached. It doesn't really matter what the c value is, other than the fact that the x squared has a coefficient of 1, or it's all by itself, as we say kind of colloquially, and then the b value is even. If those two qualifications are met, it is kind of a great thing to be able to immediately put it into vertex form. It's kind of quick, fast, and easy to do it in that method. The second method would be to put it into factored form. Now, the only way we can really put it into factored form is if the equation is factorable. Factored form looks like this. We have y equals a on the outside still, x minus p, x minus q. What you'll notice here about factored form is that there's two separate sets of parentheses, which means there are two separate sets of roots, or two real roots for this parabola. So again, the only way to use factored form is if the equation actually is factorable. We would always check for our a value to be negative as our very first step. We would check and make sure that there is no common term that can be factored out from the whole standard form equation. We would also check and make sure that it's not what's called difference of squares, one of those special cases we've been talking about so much. Difference of squares will always be written in factored form when we do the actual difference of squares factoring. If all three of these things have been done and worked on, then we would then do the diamond factor to see if the problem can actually be factored. If it can be factored, we would then go and do our generic rectangle. In order to find the two different factors. Now, if both of these methods fail, if we can't do vertex form because it doesn't meet these qualifications, and if we can't factor it because it doesn't meet these qualifications, well, then we're stuck with our third method, which really is the best. It's like the best way because we get to do all the math, which is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We use the quadratic formula, or we could use the quadratic formula for any quadratic equation that we're given. Anytime we have y equals ax squared plus bx plus c, when a is not 0, we could use the quadratic formula to solve for the roots of the parabola. Now, it should be our default method, like if the vertex form doesn't work and if the factored form doesn't work, then we do the quadratic formula as like our backup plan. So we're going to look at three different problems today, and we're going to talk about why we would choose to use each of these three different methods to solve these three different problems. Our first example problem